Good day, everyone. I am Mr. BJApare, and today I will be presenting the topic the plate tectonics. According to the map, this is how our Earth looks like. You can see the different continents as well as the different countries around the world. Okay, according to the real one or the globe, this is how our Earth looks like. You can also find the different continents, and since our Earth is round. Okay, how does the Bible describe the earth when it was first created? In the book of Genesis, chapter 1, verse 9 to 10, in the New International Version, it says, in verse 9, it says, "And God said, Let the water under the sky be gathered to one place, and let the dry ground appear. And it was so." Verse 10, God called the dry ground land, and the gathered waters he called seas, and God saw it was good. Probably, during that time, during the creation, the land is gathered together and the seas is also gathered together. Now, this is the structure of, according to the description. Now, in this world, Pangea, how come that from this one, it came to the present day, according to the map, it now looks like this? Okay, let's begin with the continental drift theory. Alfred Wegener's theory of continental drift significantly challenged previous views on Earth's structure. So as you can see here, we have the Pangea, where the Earth is gathered when the land is gathered together and the seas is also gathered together as one. We have now the Laurasia and Gondwana, when the Earth or the land was separated in two, and we have now the modern world. By the way, who is Alfred Wegener? He was born on November 1880 and also died in November 1930. He lived in only around 50 years. Was a German climatologist, geologist, geophysicist, meteorologist, and polar researcher. He proposed the theory of continental drift, the idea that Earth's continent moved, despite publishing a large body of compelling fossils and rock evidences for his theory between 1912 and 1929. It was rejected by most other scientists. It was only in the 1960s that continental drift finally became part of mainstream science. That means before 1960s, his theory, this continental drift theory, was disregarded by other scientists. Okay, according to his theory, that Earth's continents were once part of a supercontinent called Pangaea, with evidence from fossils and geological features supporting his idea. As you can see in the figure in the right, you can find different organisms, living organisms that become fossilized, and their fossils can be found on the different continents around the globe. Okay, so Wegener have also some evidences in his theory. We have here the puzzle continents, the fossils, and the type of rocks. So in here, a good fit of edges of continents for the puzzle, and similar rock structures are found on different continents. As you can see in the different structures of the South America and the Africa, it seems that they are like a puzzle. And also we have the Antarctica, the India area, as well as the Australia. They are a puzzle continent. Okay, that is one of the evidence of Alfred Wegener in his theory of continental drift. Okay, for example, East Coast of America, South America, and Western Coast of Africa have good visual fits. Okay, next one is the fossil of old animals that support Wegener's hypothesis of continental drift. You can find different, as we have discussed in the previous slide, that we can find different fossils of early organisms that can be found on the different parts of the continent, even though that they are already far separated by sea, but these fossils or these organisms that lived long before have fossils that can be found on the different continents. So possibly, according to Wegener, he used this as an evidence, since probably that these continents are once a joined land, form of land, why these organisms are The fossils of these organisms can be found on different areas. We have also the matching ancient rock assemblage and continental shelf. Okay, so in here, in the areas in the part of North America as well as Africa, as well as in the Great Britain, there are several similar rock assemblage, as well as in the part of the Africa, as well as I think this is in the Peru, or I'm not sure, this Chile. Okay, this of South America, there are similar structures of ancient rocks that can be found in this country, though as of now they are hundreds of kilometers away from each other. So those are some of the evidences that Alfred Wegener used to support his continental drift theory. Now, you have also the plate tectonics. Tectonic plates are large sections of Earth's lithosphere that interact with one another through various movements. The lithosphere and asthenosphere play crucial roles in the movement of tectonic plate. What is asthenosphere? This is a portion of the Earth below the lithosphere. We can find some figures as we go on with this topic. Okay, so lithosphere and asthenosphere play crucial roles in the movement of tectonic plates. Okay, this is this is where the asthenosphere is located, still in crust and probably partly of the mantle of the Earth, where magma are formed. Okay, so the lithosphere is the outer part of the Earth as well. So this one, evidence such as ocean floor mapping and earthquake pattern supports the theory of tectonic plate. Okay, why? Okay, as you can see here, these are the different locations of the earthquake. And as you can see, each location, each earthquake are only located in the different areas where fault are located as well. Okay, there is a fault in that area, including, as you can see in this picture, this is the Pacific Ring of Fire where our country, the Philippines, is part of. Nara diri ang Philippines, and that's the reason why you have also a lot of volcanoes and we are experiencing earthquake in throughout the year. It's because we are part of the Pacific Ring of Fire, and the different earthquakes na siya pattern that only follows on the faults that goes through around the Pacific areas. Okay, and this is called the Pacific Ring of Fire. Okay, so there is a pattern. There are 7 major plates on Earth that are moving extremely slowly. We cannot notice that these faults are moving, but because they are extremely slow but continuously. Some major plates includes the African, Antarctic, Eurasian, North American, South American, Indian, Australian, and the Pacific plates. The intermediate plates includes the Caribbean, the Cocos, Nazca, Arabian, including our Philippine plate, Juan de Fuca, and the Scotia. We have also two main types of plates. We have the oceanic that can be found in the oceans, and also we have the continental plates that can be found on land. Now, these are the different plates as viewed in or shown in the map. The theory of plate tectonics explains natural phenomena like earthquakes, volcanic activity, and the formation of mountain ranges. Since, as we have discussed in the previous slide, that earthquake follows a pattern, and the pattern that is followed is where fault is being located. So the earthquake is dito nag-start together with the volcanic activity. That area nga near ato nga fault is naa po dito ang mostly volcanic activity and as well as mountain ranges. Now, we will discuss on the plate boundaries. There are 3 types of plate boundaries. We have the divergent plate boundary. This plate boundaries is depending on its movement. Okay, we have also the convergent and we have also the transform plate boundaries. Okay, as you can see here, the motion of the divergent is spreading and it is constructive. The oceanic lithosphere is created. Okay, for the convergent, when two plates move towards each other, the divergent is two plates away from each other. Okay, there is a volcanic activity on this one. Okay, there is a ridge or a reef that will be created. For the convergent, it's a subduction. One part or one the plates will subduct going down on this one, and it is destructive. There will be a trench that will be created. I'm sure that you are familiar with Mariana Trench, the deepest part of the earth that is located near our country in the Philippines, because Mariana is can be found in the Pacific areas. Okay. Now, for the volcanic activity, yes, still there is a volcanic activity when there is a movement, a convergent movement of these plate boundaries. For the last one, the transform is the motion is lateral sliding. They are sliding past away from each other, and it is conservative. The lithosphere neither created or destroyed. Ang maguba lang ani is ang mga karsada kay maputol, di ba no? But there is no destruction of the lithosphere, not compared to the convergent where the lithosphere is being destructive since it will be subduct. So there is no major effect and there is no volcanic activity on the transform plate boundaries movement. Okay. Divergent boundaries when two plates are moving away from each other or moving apart from each other. As you can see here in the picture on the right, the two plates are moving away from each other, and then a new reef was being created or a ridge was being created. It was the new one is being constructed. Oceanic lithosphere was now being created. Okay, if this happens inside the ocean. We have also the seafloor spreading, okay, as the effect of the convergent, the divergent plate boundary, the plate movement. Okay, the seafloor spreading. There was a new young seafloor that will be created when plates will move apart from each other. As you can see here in the illustration, that when two plates move apart from each other, a new mid-ocean ridge will be created. Okay, so in the middle is the youngest one, and the outer part is the oldest one, since it continues moving slowly apart from each other. Okay, next one we have here now the mid-oceanic ridges that was being created when the plates will move away from each other. Okay, another one is the Rift Valley Formation that will be formed as well if the situation or the movement will happen in the continent or in the continental areas. Okay, so Rift Valley Formation. For the convergent boundaries, when this is when plates come together. Okay, as you can see here, one plate rises that form mountain ranges, and one plate subducts. Okay, according to our previous slide, this is a destructive, since so if this happens in the ocean, in the oceanic plates, a trench will be created, and when this happen in the continental plates, mountain ranges will be created. Okay, so we have some familiar ranges like the Himalayas mountain ranges, where the tallest mountain in the world is being located, the Mount Everest. Okay, we have also here close to us the Kitanglad mountain ranges as well. Kinaapoy mountain ranges very close ato ada Kitanglad. Okay, and that is a product of a convergent plate boundaries when two plates are moving towards each other. Okay. Next one here, we have the oceanic to oceanic boundaries. So as I have said a while ago, that if this happens in the ocean, then a trench will be created. Okay, to oceanic plates collide, the denser plate sinks below the lighter plate and eventually forms dark heavy basaltic volcanic island. Okay, that is the oceanic. For the oceanic continental boundaries, okay, the oceanic plate undergoes subduction volcanic arc crisis on land. Okay, the oceanic plate, since it's heavy, then it will subduct. It will go down, and in the continental plate, it will form a volcanic arc. Okay, for the continental, as I have said a while ago, that mountain ranges will be created when one plate will subduct and the other plate will rises. Mountain ranges will be created. Okay, large slabs of crust against each other. This results in a very little subduction as most of the rock is too light to be carried very far down into the dense mantle. Instead, the continental crust at these convergent boundaries gets folded and thickened, forming great mountain chains of uplifted rock. So as I've told a while ago, that we have the Himalayas mountain ranges, and we have also close to us is the Kitanglad mountain ranges in Bukidnon. Okay, that is an example of the continental uh, plate boundaries, continental to continental. The last one is the transform plate boundaries when plates sliding past each other. Okay, so this is not destructive as well sa in the lithosphere. However, it is destructive on the road. Okay? And also kung naay houses nga maigo. As you can see, the road is no longer attached to each other since it moves, the plate is moves, slide past to each other. Now, this transform faults occurs between margins of the continental crust. A well-known example is the San Andreas transform fault in California. This is the example of the San Andreas transform fault. Okay, nag-move siya past sa each other. Wala siya nagpalayo sa iyahang kuan, sa iyang kauban, pero nag-move siya past. Okay, patakilid lang iyahang movement. Now, if this happen in the oceanic transform fault, so this is how the structures looks like. Okay, it will cut the mid-oceanic ridge. Okay, as we have discussed in the divergence plate boundaries nga it will form, if it happens in the ocean, it will form a mid-oceanic ridge. And if that mid-oceanic ridge will be hit by kuan, affected by the transform, then mo ni siya, this is now the structure of the mid-oceanic ridge. Naglagyo na siya, wala na siya kuan na nagkuyog na putol. Okay, an example of mid-oceanic ridge is in the um siya sa American and the African in the middle, Atlantic. Okay, the Atlantic Ocean. Okay, now measuring plate motion, tracking plate motion from space. Today, we can track the current direction and speed of plate motion with ground surveying techniques using laser electronic instrument and by space-based methods such as satellite networks. Since plate motion are a global scale, they are best measured by satellite-based methods. Di nato makaya nagsukod-sukod lag by ruler, no? It can be measured using a satellite. The three most commonly used space-based techniques are very long baseline interferometry or VLBI. We have also the satellite laser ranging or the SLR and the global positioning system or the GPS. Among these three techniques, GPS has been the most useful for studying plate motions to date. GPS is very common nowadays even in our cell phones. When we are traveling, GPS is very helpful. Okay, for the satellite laser ranging, this is how it looks like. So naa siya mga stations in the different continents, and then it will be tracked from those satellites nga naa dito sa ibabaw. The stations will be tracked kung unsa na siya kalayo ang iyang distance. If there are some movements in its distance, kung naabay movements. We have also the global SLR stations, mo siya. Okay, so it has different stations. Then using the satellite, then it will be measured the distance from one station to another in each year kung naabay movement. Okay, so this is how satellite laser ranging mo work. Okay, next one is the very common, which is the global positioning system. GPS is very common nowadays. So makita nato, magamit na nato, we can use GPS every time na gyud. Kay we can see the map all over the world. There are a lot of free nga mga applications that uses GPS. Most of the cellular phones nowadays are connected to GPS. Okay. So this is the plate motion as seen by the GPS. So naa siya mga ginagmay nga movement. Now, the question is what drives plate motion? Ngano man nga move man siya? Why there is why we have those three types of plate movements? The plate movements. Why is it become it moves? Okay. We have two. The first one is the convection current. Okay, as we noticed in the previous slide that below the lithosphere is the asthenosphere, and the asthenosphere is medyo humok na to siya dito nga area. It's because it is a molten rock. Okay, those are magma na to dito. Init na kayo to dito nga area, and there is a movement that happen. Okay, drive the movement of Earth's rigid tectonic plates in the planet's fluid molten mantle. Okay, so in here, as you can see in the picture, hot magma in the center rises up due to the heat. Musaka siya. When magma reaches the surface, it cools and sinks back down, creating a circular pattern of movement. And through this, that forms into a convection current that drives the movement of the plates. Okay, so we have here the convection currents. As you can see, nga in the mantle, there is a molten magma nga naa dinha, and due to the very high temperature, it will rise, forming a convection current. Mag-rotate na din siya. According to one theory, convection currents in Earth's mantle drag along tectonic plates. Here, the currents move two plates apart. Okay, so since it moves, nag-move man siya, it follows the lithosphere or the crust follows the movement of the convection current, and then mid-ocean ridge was being created, and this is on the divergent plate boundaries. Okay, plate movement. Next one here is the crust density. Now, for the oceanic plates, it is very dense or heavy. Ang dito sa kaninyang dagat, it sinks or it subducts underneath the continental crust. Continental plates lens dense and it is lighter. That's the reason why it will rises. While the oceanic plates will subduct, the continental plates will rises, and then this also happens on the when two plates will move towards each other, and that is the convergent plate boundaries. Okay, as you can see, with it happens in the oceans, a trench will be formed, will be created, and also a mountain ranges will be created. Okay, that is on the crust density. Okay, rises above, these continental plates rises above the oceanic plates. Okay, so that's the end of my presentation on the tectonic plates, including the discussion of the three different plates boundaries. God bless and more.